Hi, today we're going to do Kal Academy problem set 2, problem number 9. So this problem says, given a 2D array, print it in spiral form. So we are going to be given this 2D array, which has all these subarrays and these integers within them. And what we want to do is we want to go through it this way, down this way, then this way, then back up again this way, and then to the right again. So what would that look like? If it's 1, 2, 3, 4, so 1 to 16, the output should be 1, 2, 3, 4, then 8, 12, 16, 15, 14, 13, 9, 5, 6, 7, 11, 10. So it's going in this sort of, inward, downward sort of fashion, like so, right? Going as a spiral. And we're going to do this in a time complexity of O of n times m, because there's n elements, n arrays, and then m elements within those arrays that we have to go through. And the space complexity is a little complicated here. It's going to be n squared by m minus 1 divided by 2. That is, of course, because for every n, we're going to minus 1m from it. And we are going to then remove the top row and the bottom row, or n. So we're going to basically divide n by 2 upon each iteration, because we're going to lose 2 rows, entire rows, for each iteration. So let's see how this is going to work out. This is going to be a recursive call. So what we're going to end up doing here, let me just pull this up, is we're going to, at the very end, we're going to return the recursive call of this function, and we're going to pass back in the 2D array, which we will be manipulating throughout this process. So let's see, and we're going to have a base case where we ask if the 2D array has nothing in it, it's an empty array, and we're just going to exit and return. If it does have something in it, we're going to loop over it. We're going to say let I equal 0, just a basic for loop. And we're going to do about 4 loops through this. We're going to have 4 separate loops, 1 for each row and column. Okay, so we're going to call this our top row element. We're going to call it array, 2D array at I, at the 0th position at I, because the top row is always going to be at the 0th element here. So we can just assume that that's just going to be the top row is always the 0th element, the 0th n element. And then we are just going to then console log, because all we have to do is print. So then we're going to print this element, and then once we print it, we are going to then shift this guy out of this array, because we don't need it anymore. Which will then, of course, move everything, have to shift and reindex everything. And after we do that, because if we had just one, if we just had one array in here and we then shifted it out, we would then have to do this check again, because we can't loop over an empty array, so we have to ask the same question. If the 2D array is now empty, then we want to return. But if it's not empty, then we're going to loop through the right column going down. So let's see, we're going to say from j is less than the 2D array length again. And this time we actually want to go down the whole thing, and we're going to say that this is the right column element. Right column element. We set it equal to the 2D array at the last position. So we'll say the j element. So it'll be, you know, starting in this row. So we'll start in this row, and then we'll go down. So j at the it will always be the last element of each n. So we're going to say 2D array dot length minus 1, which will give us, in this case, 8. And then we are going to console log that right column element, and then we are going to then pop it off because we don't need it in there after we have logged it to the console. And it's 2D array at j, and then we're going to pop, because the j represents that subarray. So then we just go pop the element off of that subarray. And essentially, we're going to repeat this process for the bottom row. So the bottom row is going to look a lot like this top row, and then the left column is going to look a lot like this right column. It's just going to be in the reverse order. So then for the, let me change this up because we're running out of space here. Turn print spiral to the array. Okay, so let's go for let k, and we're going to say it's going to be the last row, the last nth row. So it's going to start at the 2D array dot length minus 1, and let's see, 2D array. So it's going to be the 2D array at the 2D array of length minus 1. So that is saying very last element of there. That's where we're going to start our k at, and we're going to say, well, k is k is greater than or less than equal to 0. So we're going to go from here to that way. We're going to decrement the k, and we're going to say the bottom row element is going to be equal to the 2D array at the 2D array dot length minus 1 at the kth element. So it's always going to be the last row. That's what we're saying here. It's always going to be the last row, and it's going to be the kth. So we're going to start at 16 and then move our way down towards 13. And then we're going to console log that. Bottom row L, and once we finish that, just like we did up here with the shift, we are going to pop. Dot. Pop. Okay, so far that takes care of our top row, our right column, our bottom row. Now we just need to do our left column. So now we're just going to say let L equal the 2D array dot length minus 1. And we are going to go from, we're going to decrement L all the way to 0. L minus minus. And we're going to say let left column element. So we're setting it to be the 2D array dot length minus 1. So that means we're going to start at, once we've popped this out, this has been popped out, and once we've popped all these guys out, means we're going to start at 2D array length minus 1. We're going to start here, this position, and since we're starting at this end, we want to decrement the n from the last guy towards the 0th guy, so that's why we made it that. So we're going to set it equal to the 2D array at the L position, and it's always going to be the 0th item. So we're going to say, all right, it's going to be that 0, then we decrement the L, and it's going to go from here to here, which will be 5. So then we're going to log console.log the left column element, and as we do that, we're also going to be shifting out this element. So we're going to say from the 2D array at the elf position, let's shift it out. So we're going to remove these guys each time after we print them. And then once we shift those guys out, we would be left with 6, 7, and 10 and 11. We'd recursively call print spiral, which would pass those two arrays back in, and would do the check. There's a length of 2 still here, so there's something there. So we go back in, we print out the 6, print out the 7, and we remove this entirely. And we go downwards, so then we start at the 11, which we would go here. It would pop off the 11, and then we would go to the bottom row, and it would go this way to then print out the 10. Then we would have popped that off, and then by that time we would have completely removed this. There wouldn't be any N or any M left, and by that time we would have printed out everything, and then we would have returned, and we'd finish the problem. So that's it. Thank you.